In this video, we will discuss some of the testing techniques. Like we said, the classical testing techniques, all the classical testing techniques apply to the Agile testing. It's not that we are going to perform something new. But we will take a look at some different problems that arise with the Agile implementation, with the Agile methodologies. For example, the oracles problem. The oracles problem is a well-known problem from the early days of the testing. So let's reply, what is the oracle? The oracle is a principle, it is a model or mechanism by which we recognize a potential problem. So when we say that something works, means that actually it appears to meet some requirement to some degree. We cannot be absolute about saying like, yeah, it works, it absolutely works. No, it just means that there is a requirement, there is a part of a requirement that this functionality meets to some degree. It is still unknown to which degree, and maybe it doesn't matter. Maybe this degree of consistency is enough for the stakeholder. And what are the heuristics? We said that Oracle is an heuristic principle, so what are the heuristics? Heuristics give ideas. They model our ideas, they help us bring ideas further. So their purpose is to discover the solution to the problem. The heuristics are just like oracles. The heuristics are not perfect. They cannot be perfect, they are just models. Sometimes they work, sometimes they not. We have to decide in which parts and in which context the certain heuristics will work for us. So in regards to the oracles problem, Michael Bolton and James Back created consistency heuristics. Consistency heuristics is about the testing without a map. Okay? So this means that as in Agile testing, many times we will not have a map, we will not have a detailed requirements or test cases. We have to use different kinds of oracles. We have to use different mechanisms to recognize potential problems in the software. Why? Because there will not be a super defined requirement saying this and that should happen, and if happens this and that, then it's wrong. We have to decide on our own. These oracles can be combined, and like I said, they're not perfect. They can fail in different occasions. So the consistency heuristics are about the testing without the map. These heuristics, like we said, can be combined, and we will talk much more and practice these heuristics in the exploratory testing course that will take place later on. So let's just go quickly through a few hiccups and see what's all about the hiccups. So the first is the familiarity. We expect the system to be inconsistent with the known problems. We know there are some problems in the system, and we expect the new implementation to be inconsistent with the problems. That means we expect it not to fail in the places we know it usually fails. The next one is the explainability. We expect the system to be understandable. If it's too complex, if we cannot explain it, then something is wrong. How will the end user understand the system? Next is the consistency with the world. We expect the product to be consistent with those things we know about the world. You could also call it the logical behavior heuristics. You know, if you know something about the world, if we happen to know, if we happen to have some information, for example, let's say about the shopping process, or about the online shopping, then, you know, and if our product does something strange, we can say, you know, this is strange, this is not what is usually done. The next, we have a history. We expect that the behavior we have in the system is consistent with the history. This means there are no unwanted changes. And if there are some changes, we can ask, maybe this is a bug or maybe not. Maybe someone actually desired this to happen, this change to happen, but did not document it. So maybe it's a bug or maybe not, but we have to report it because it is not consistent with the history of a product. The next is the image. Every company wants to project a certain image to their customers. We expect the product to be consistent with the image we want to project to our customers. So let's say if you're if there is a banking product and we're not stable enough or we are having rounding errors, then whoa, what kind of image are we presenting to our users? The next one is comparable products. This one is quite nice because nowadays in the market there are so many similar products, and we can always argue that and this and that product that is the competency of our company, the behavior is different. It is not consistent. So if users want to switch from one product to another, they will have difficulties, and this may make them consider not going for our product, because the learning curve is just too steep. The next is the claims. We expect the system to be consistent with those things we say about it. And where do we say it? We say it in requirements, in documentation, in help files, etc. The next in our line is the user expectations. We expect the system to behave in the way we think users want. Tester will never be a user. We have to identify ourselves with the user. We have to take a look. We have to do a bit of a research to know what are the users, who are the customers of our product. This is the part of the project context document, if you remember that document. The next is the purpose. We expect the system to be consistent with its purpose. For example, if the purpose of the system is to perform shopping, to add items to the cart and to check out, but at a certain point of the process we offer something completely different, then maybe it's not consistent with the purpose. And the last one is about standards or regulations, in which we expect the system to be consistent with externally imposed requirements. For some systems, for some projects, we have externally imposed requirements we have to comply with. In terms of the classic test design techniques, we find 2 recommended books that will explain different testing techniques in a way that are easily understandable and you can apply them quite quickly. The first one is A Practitioner's Guide to Software Test Design by Lee Copeland, and the second one is Software Testing Techniques by Boris Weiser. These books explain some of the basic and essential software testing design techniques, such as equivalence class testing, boundary value testing, or decision table testing. There are a few others, and most of these techniques, what they do is they help you reduce the number of test cases to a manageable level, or they help you implement enough test cases to cover most of the business process. Next in our line, next idea for the test design techniques are testing tours. Testing tours are techniques by which we use the tour metaphor to guide our exploration or testing, in case we have oracles. We will talk more about testing tours and some test design techniques in the future courses. For your information, there are several links and several points you can learn more about testing tours, and you can find how Michael Kelly prepared different tours to cover the oracles heuristics and a few others heuristics. A next trick for the Agile testers are cheat sheets. Well, it's not only for Agile testers, it's for any tester at all. So cheat sheets are quick reference guides that you can use at any time in your testing. You can create your own list of heuristics or cheat sheets, but we provide one specific prepared by Elizabeth Hendrickson, James Lindsay, and Dale Emery, and this is one of the most popular ones, and you can find different quick tricks or quick wins for your testing. You can print it and have it near you, and it will provide you a huge amount of test ideas for your everyday testing. Once you're familiar with them, just as with heuristics, try adding some of your own. The same goes for the skeleton keys. A skeleton key, or also known as a pass key, is a type of a master key that can open different locks. In testing we use skeleton strings. As a matter of skeleton key, it can open doors to so many bugs, so many defects when we deal with input or text boxes. As with cheat sheets, it's extremely helpful to have a set of skeleton strings at your hand, so you can use them anytime you want in your testing. There are a few examples of skeleton strings you can see at the links we provide in the course material.